So, again, when the sun fuses 4 atoms of hydrogen, it makes all of this mess happen, okay? There's one last thing I want to label in here. This atom we made. Can anybody figure out what element this is? Can you figure out what element this atom was? I probably should have labeled this sooner, but what element is this? Yes, that is helium. Does that make sense? That is helium, and we can tell because it has 2 protons. So I'm going to add that in right there. Okay? All right. And in case you're interested, I will post up a photograph of this full diagram in the Discord after this lecture is done. Okay, in case you can't see some of these parts very well, I'll post a picture of it. Now, let's take this whole thing and simplify it. Okay, let's simplify this down. Okay, let's make it way easier to digest. Let's write it as a little bit of a formula. Okay, and in this formula, we're gonna have an arrow. There we go. Pointing to the right, and on the left-hand side of this arrow, we're just going to write what the sun uses in the fusion, and on this side, we're gonna write down everything that survives the process. Okay, so if we look over here, what's the only thing that the sun is using? What are we gonna put on the left-hand side of this equation? What is the sun using to get all this going? I'm crossing off all this stuff because this is what we're looking at over here. What is the sun using to get this process going? 4 heliums. That is correct. 4 hydrogens. My bad. 4 hydrogens. That is correct. So on this side of, oh man, are you freezing on me again? Are you freezing on me again? Reboot. Reboot. Nope. Reboot one more time. There we go. So on this side, like you guys were saying, it's 4 hydrogens. So I'm just putting a big 4 there and an H to mean 4 hydrogens. The sun only uses 4 hydrogens to make this happen. Now over here, what do we make? Well, we make helium, but we only make 1 of it. So I'm just going to write helium. Okay. We make neutrinos. We make 2 of them. So I'm going to write plus 2 neutrinos. Now this right here, this is a Greek letter. You probably haven't seen it before. It kind of looks like a V in the wind, or like a raptor claw or something, just or a tornado. That's the Greek letter nu. We usually spell N-E-W, and the reason we use that symbol is it's neutrinos, so we use the Greek letter nu, okay? And then we make gamma rays. How many total gamma rays does the sun make every time it does this process? How many total gamma ray photons all together are being made? 6. That is correct. It's 6. If we put them all together, if we add these 2 to these 4, we get that. Now, I'm not going to list the positrons because them and the electrons don't survive the process. They're kind of like an intermediate step. They're not there when this is done. So when we're writing down here, we just want to say what does the sun put in and what does it get out. So all of this mess breaks down to this one formula right here. And don't worry, the rest of the lecture is not going to be as technical as what we're doing right here. We're almost done with this. So the sun uses 4 atoms of hydrogen to make 1 atom of helium, 2 weird ghost particles, that's your neutrinos, and 6 gamma rays. Okay? So this is how the sun makes light, all right? A couple of things we should say about this before we move on to more interesting stuff. The sun is using 4 atoms of hydrogen to make a new helium. So what's happening to the number of atoms in the core of the sun over time? Is the number of atoms staying the same? Is the number of atoms going down? Or is the number of atoms going up? Keep in mind that these are not atoms, and these are not atoms either, okay? It's going down. It's going down. The sun is slowly losing atoms in its core. The amount of hydrogen is decreasing over time faster than the amount of helium atoms we're building up. So this is what will cause the sun to die one day. When the sun runs out of hydrogen atoms to make this fusion go, it won't be able to make light the way it's doing right now anymore. And that's when the sun will die in about 6 or 7 billion years. So we still got a pretty big gas tank going, but it is depleting. We're getting close to half of the sun's core being depleted at this point. Yay. All right. Now, okay. Last couple things I want to say about this. The sun is making gamma rays. That's the type of light it makes. Is gamma rays the main kind of light that's coming out of the sun? No. What's the main kinds of light that are coming out of the sun? Yeah, that's correct. Visible and UV. The main types of light that the sun is giving off is visible and UV. So something must happen to this light that is made in the core of the sun on its way out of the sun to cause it to change into the visible light and UV that we see, okay? The next thing is this. Last thing I got to say about this. We said this was happening in the core. And I also said we cannot see the core. So how do we know that this is how it's happening? There's a whole bunch of ways you can make light. If we can't see the core, how is it that we know that this is what's making the light and not like a bunch of hamsters hooked up little hamster wheels attached to light bulbs, like powering the light bulbs with their little hamster feet? How do we know it's this? This one, I don't actually think you guys will be able to know this one. Let me ask you this. Remember these ghost particles? These ghost particles. These helium atoms, they're going to be trapped in the center of the sun. They're going to be trapped in the core because there's a whole bunch of extra gas on top. And that's the whole rest of the sun is pressing down on that core, keeping the helium in. Is that gas going to block the neutrinos? Is the gas of the sun going to be able to block these neutrinos? No. No, it's not. Remember I said neutrinos can go through your body, they can go through walls, they don't like to interact with other matter. So that means when they're made, they immediately leave the sun. And the sun is doing this billions and billions and billions of times a second. So that means the sun is constantly shooting out bajillions of neutrinos in all directions. Hamsters don't make neutrinos. Potato batteries don't make neutrinos. Regular fire doesn't make neutrinos. But this fusion process does. So if we can detect neutrinos coming out of the sun, then we can prove that this is how the sun is making its light. And we have done that. We have made some of the craziest sci-fi looking devices to detect these neutrinos. Here's an example right here. Here is a solar neutrino detector. This is a giant detector placed underground to catch neutrinos from the sun. It's very, very complicated how it works. But we place these underground because the neutrinos of the sun can penetrate through the ground and hit this detector, and that shields it from other possible disturbances But that also means what's going through your body right now, every single second. What's going through your body every second of every day? Neutrinos, and a lot of them. Neutrinos, and a lot of them. So right now, literally billions of neutrinos from the sun are coming in one side of you and going out the other. And you're not even protected at night, because if this was the Earth and the sun was over there, the neutrinos of the sun will go through the Earth and come out the other side and just go through you then, right? So we're constantly being bombarded by these things. But don't worry, again, they're not going to hurt you because they don't really interact with your body almost ever. Every once in a while, one of them will bounce off of you. But for every one that bounces off of you, billions and billions go through you, okay? And somebody is asking what happens to them eventually. They essentially will just continue to fly through space forever. There's just neutrinos flying all over the place out there. From every star is sending out tons of neutrinos, but they don't tend to affect much of anything. Again, they every once in a while will hit something, but in such small numbers that essentially what usually would happen is they'll bounce off of whatever they hit. Not enough to actually cause any noticeable effect.